Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy. So that's it for U-substitution. If you have any questions, just let me know. But now we're going to move on to the next topic, which is exponential integrals, or really just integrals with exponents in them. These problems are, in my opinion, kind of fun compared to the other ones. In my opinion, they're actually too easy. I don't like them. But for you guys, they'll probably be harder because they look funny. But that's okay. I'm here. I'll hold your hand. So the first thing I'm going to tell you is we're going to look at this first problem here. The integral of e to the x dx. Some of you might know this. Some of you might not know this. If you've met with me already this week, hopefully you know this. But this integral, if you don't know it, I want you to first think about the derivative of e to the x. If I asked you what's the derivative of e to the x, hopefully you'd tell me it's e to the x. It's the derivative of itself. It's the only function in the world that does that. And you would be correct. Now, if the derivative is e to the x, then shouldn't the integral also be e to the x? And that would be correct. The integral is e to the x plus c. And that's going to happen. It needs to be e to the x in order to be itself. If you have e to the x, the integral is e to the x. And the reason that's important, and I really want to make this point, is because if I have the integral of, let's say, e to the u du, well, then this integral is equal to e to the u plus c. Now you're starting to think, hopefully, U-substitutions and exponential integrals. And some of you hate this, and others of you are getting excited inside. And then there's a third group of you who really don't know what's going on, and that's okay. You are in for a rude awakening over the next two problems. So here's problem number 2. I have the integral of e to the 7x minus 1 dx. What is this integral? So first of all, I cannot just say it's e to the 7x minus 1 plus c. This is wrong. You cannot do this. This is not right. Instead, what we need to do is we need to do a u-substitution. And whenever you have e to whatever power, most of the time, the u is going to be that power. In other words, u is equal to 7x minus 1. This is the right u for this problem. Then, as usual, I'm going to say du dx, the derivative, is equal to just 7. I'm going to multiply both sides by dx. So du is equal to 7 dx. And then I divide both sides by 7 to solve for dx. So du over 7 is equal to dx. I can plug that in right there. I can plug in my u. I'm going to get the integral of e to the u times du divided by 7. Now, hopefully, most of you know how to take this integral by now, but for those who don't, that's fine. You just need to practice on your own for a little bit, and you'll probably be fine. But this 7 in the denominator, I'm going to write out in front of my integral. Why? Because it's a coefficient. So now I have 1/7 e to the u du, just like this. I know this integral. Hopefully you do as well. And that's because the integral of e to the u is literally just e to the u. This is equal to 1/7 e to the u plus c. It's not my final answer, though, because I still need to plug in for u, which was 7x minus 1. So the final answer will be 1/7 e to the 7x minus 1 plus c. Final answer. Any questions?
So with the problems with the e that have something in the exponent other than other than x or u, you have to use u substitution because it's chain rule, right?
Exactly.
Okay.
Any other questions? Okay, now let's look at just another example real quick. This one will be slightly harder. Let's say I have the integral of 2x times e to the x squared power dx. So same idea. The first thing we're going to do is say u is equal to the exponent, which is x squared. By the way, if you choose e to the x squared, if you choose e to the x squared as your u, this is wrong. This is going to get you a bunch of problems downstream. So it's just the exponent. It's just x squared. Then, again, we take the derivative. Du dx is equal to 2x. Again, we're going to solve for dx. So du equals 2x dx, and ultimately du divided by 2x is equal to dx. Same thing we've been doing all night. So now this is equal to the integral of 2x, because again, we don't touch the 2x, that's not what we're doing here, times e now to the u power, and then dx got replaced with du over 2x. Again, did I choose my right u for the u substitution? Yes, because the 2x's cancel here. Great. I'm left with the integral of e to the u du. And again, hopefully we know this integral. It's literally just e to the u plus c. But my final answer, still need to plug in for u. So final answer, e to the x squared power plus c. Final answer. Any questions on that one? Yeah, very fun. I love exponential integrals. I'm sure you're lukewarm to the concept, but the better you get at it, the more fun it will be, I promise. Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.